Hello, Internet, and thank you very much for tuning into the Cloud Native FM podcast. You are listening to the host, Saim, co founder of Cloud Native Islamabad community and the organizer of the very first KCD Pakistan. Good morning, good evening, good afternoon, regardless of where you are, or watching, or listening to me, or watching, or listening to the recording. Very, very warm welcome to the show. A show which brings in the latest and greatest news from the CNCF ecosystem to help you keep up to speed with what's going on, where you need to be focused on more, and where you meet the brave mind and awesome community members, co founder of the most watched open source project. And as of today, 7th April 2023, I am joined by Rob Sumsky of EdgeBit and Adolfo Garcia of Chainguard on this debate. Open source code remains a concerning and ongoing source of vulnerability in the software supply chain, as seen in the recent 650% year over year increase in attacks directed at exploiting weakness in upstream open source ecosystem. An SBOM lets engineer and security teams verify, discover, track all dependencies and supply chain relationship between components in their software. While this unique snapshot of software provenance helps producer and vendors identify and convey vulnerabilities to user and asset owner, it is not the most expedient approach to vulnerability management. A VEX artifacts help software producer and vendors more quickly and efficiently identify, track, and communicate vulnerabilities and their potential to be exploited. VEX are not intended to replace SBOMs, rather, they should be maintained separately but work to support each other. This episode walks you through a roller coaster ride of OpenVEX. OpenVEX is a complementary to SBOM, allowing supplier to communicate precise metadata about the vulnerability status of products directed to consumers and end user. So without any further delay, let's go straight to Rob Sumsky. Thank you very much for being on the show, and Adolfo Garcia from Chain Guard. So let me go to Rob. I hope I made a good intro of the today's podcast, but it's your turn now. Can you introduce yourself to our audience, and then we start the proceeding?
Yeah, hey everyone, happy to be here. I'm Rob Sumsky. I am the CEO of EdgeBit, and we produce a holistic supply chain platform with a focus on vulnerability management and helping you get a handle on the fire hose of vulnerabilities that you're experiencing, prioritize which ones to fix, which ones you can kind of deprioritize. Happy to be here.
Thank you, Rob. And now, my friend Adolfo, thank you very much for being on the show. And just a quick intro, and then we start the topic. Over to you now.
Yeah, thank you. Hi, Rob. Nice to meet you. Yeah, my name is Adolfo Garcia or Puerco, and I am a software engineer, open source software engineer at Chainguard, a company that also deals in supply chain security. We deal in trying to make the supply chain secure by default. And I also participate in a lot of open source projects and maintain a bunch of SBOM tools.
Awesome. Thank you very much for your intro. Let's start this topic today, and we will start from SBOM, a little bit about SBOM. So for the people who had never heard about SBOM or listening or watching the show, they can understand it. So Rob, can you give us a quick intro of what that SBOM and what SBOM can do for you?
Yeah, so an SBOM is a software bill of materials. And so it's really an inventory of everything that makes up a piece of software. So, for example, you've got a container that's got like a JavaScript application in it. It's all the dependencies that make up your JavaScript, as well as some of the system utilities that you get. That all packaged up together is the inventory of your application.
Awesome, absolutely. And also on going to the Adolfo, like if we are working on the SBOM and SBOM give us some of kind of metadata, what we can do with this kind of information?
Yeah, the key with SBOM is that it brings transparency to the supply chain. So before SBOM, you could take a piece of software and kind of try to decompose it to understand what's in it. But the idea with an SBOM is that you no longer have to do that. You have a file that lets you know exactly what you're dealing with. So all of the, just like Rob said, you have all of the list of the dependencies, and the components that went into how the software was built, and so you can understand all of the parts of a piece of software, how they interact together. And this lets you, once you have that information, it lets you do lots of things. Like, for example, you can, if you have a collection of SBOMs, you can locate quickly vulnerable components. You can understand how exposed you are to a certain vulnerability. For example, if you keep track of SBOMs in the past, you can know if you've been exposed at some point to a certain vulnerability just by understanding when pieces of your software were running in your stack. It lets you understand how, for example, how the structure of the software, how the structure of the software looks like. So, for example, if you take a container image, you can do this with the OCI tools, but you can also look at the SBOM, and it will tell you, okay, this has this many layers, and I'm seeing this dependency, and it fits into that image, but then it may not be. I may not be exposed in, let's say, in one architecture, but not in the other one. And and from there, we've been seeing lots of new uses for SBOM, like, for example, creating inventories for AI data sets, for example. It lets you track licensing across your stack. So you know if you have licenses that are not licenses accepted by your organization. So there's growing number of uses for SBOMs.
Yes, absolutely, absolutely. And speaking of Kubernetes, I think in Kubernetes now you can have, beginning of 1.24, you can track all these kind of information in the Kubernetes, because Kubernetes has 7 components, like 4 components in the control plane, 3 in the worker node, and combine all, you have so much information into it. So this means the industry community, the bigger ecosystem that Kubernetes is actually investing heavily, is now spending a lot of the time in the SBOM. And now the language specific tools is building today's that generate SBOM information. So Robs, can you tell us what are the different languages that supports, let's say, the SBOM format? And to get that data, the SBOM, the format, what different specification or standards we see in the industry?
Yeah, I'll start with the standards first. So there's 2 main standards. There's Cyclone DX and then SPDX. I think Cyclone DX has been around for a lot longer. I don't claim to be an expert in like the intricacies. I know it's like there's a ton of different formats of Cyclone DX, and there's an entire working group around it. And they're both supported pretty interchangeably by a lot of open source tools. So I think the most popular one is Sift, which is an SBOM generation tool, and it supports all kinds of like catalogers, they call it. And so it can detect if you've got Python or Java or Go modules or something like that, and it'll understand and generate the SBOM and the inventory for all of that. And so yeah, the open source, I would say, here is thriving in terms of SBOM generation.
Yes, absolutely. And we have a Docker captain with us, a CD Foundation ambassador and a CNCF ambassador. Hello, Batu. Thank you for joining the show. So let's go to another topic, that is when we are actually moving to the OpenVEX side as well. So as of today, like Adolfo, if we are scanning our images, where these information is coming from, how we actually making sure that the image we are using has CVEs inside, and when we actually use scanner like Trevi or Sneak or different scanners, might sometime they give you some false information, and for this false information can end up some bad result in it. But I remember when I started development in Angular, on that time we don't think about the container images, but think about the libraries we're using, and we want them to make sure. And remember, when the first job, I scan the images and want to make sure these CVEs are actually going to be 0, and end up by breaking 2 different components because they are heavily relevant on that project that have some CVEs, but that has a huge impact in the application. And I've seen that same happening in the container ecosystem. So now Adolfo will let us know how we extract the XCVE information and what the false information look like.
Yeah, exactly. So when you point a scanner, and this is true for particularly the 3 most popular used scanners, they will do this decomposition of the software that you're looking at. So when you point a scanner to an image, they will download the image, like crack it open, analyze everything they can about the software they find inside. And those false positives can come from several places. The first one is because of this process of trying to look at an already built piece of software. So you may start missing or confusing information there. Then the next one is, once you have the composition analysis of the image, you have to take that information and try to match it against the existing vulnerability databases. And that process by itself can be, well, it's not perfect, because there are lots of problems around that, mostly based around naming, right? Like, if I have a package called homepage in one language, is it this language or the other? Is it a distribution of that one? Has it been patched? So there's problems there. And so once you introduce SBOM into the picture, that information multiplies because you have a lot more transparency, and suddenly you can look even deeper at that piece of software. So that problem, and also, like, there's problem with cadences. Like, a open source project may fix a vulnerability, but that information takes a while until it actually reaches the scanners and the databases. So once you introduce SBOM into the picture, the problem multiplies because you have a lot more dependencies. You have that more deeper look into what you're looking at. So that's the current state today. We're entering into the SBOM era, trying to avoid getting an unhandled and an impossible, untangable mess of information.
Yes, absolutely, absolutely. And speaking of the scanner, the container images, like right now, I think another question we can add here in this topic, like, I think there is a need now to use the container images that has a smaller in size and contains only the information that is needed for your application to run. And you need to reduce all the information that your application doesn't need to care about it. So we need a smaller images. We need a pack images that have very less attack surface. So speaking of the smaller container images, speaking of this less surface stack area, we see we can come up with a policy engine that can help you make sure that the container image you are using, the base image, that is smaller, known vulnerabilities inside. But in terms of the ecosystem where it's heading to, Rob, can tell us your opinion about this is the notion of or the hurriness right now in the community around these, making sure the container images are secure, the base images, and investment is coming on. And what is your key take, like what you suggest to the audience if they are using images? What are the key information they look into the base images?
Yeah, I mean, this is a really tricky problem. I know Chainguard is doing a lot of good work in this area on the Wolfi side of things. Yeah, I think so. A lot of organizations will typically have a set of base images that you're allowed to use. And ideally that is a minimal base image that works for all of their types of applications. If they're a big Java shop, they might have needs that are very specific to Java. If they do Python or something else, or if they're polyglot, maybe they have a whole set of base images. And so typically you'll find that it's an infrastructure team that is maintaining that library, and then application teams consume it down via their CI and then layer their applications in on top. The tricky part that we've seen, my co-founder used to work at Lyft, and they have this issue where they have a set of base images and they fix CVEs in those, and then they have to rely on each application team to pull in the new version of that base image. They do some automated rebuilds, but the worst part is they actually have to do manual deploys and walk it through their canary process. And so the central security team is like, all right, great, we updated our base image. That's awesome. But what's in prod, what's not? Have this team rolled it out? Has this team rolled it out? And so it's a really large, just tracking problem. Even once you fix the CVEs, you got to make sure it actually happens out in production. And so that's a really interesting kind of threat scenario, is well, we fixed it, but it didn't roll out yet. It's no good if it's not actually live. One other interesting thing around base images is generating SBOMs of a container is always going to be better than either scanning or generating an SBOM off of a code directory. And so because you can do a lot of transformations during a container build, you can drop a lot of stuff, you can add other files in, whatever. And so scanning code is not actually a good representation of what actually gets deployed. You want to get an SBOM from the artifact itself. Now, if your artifact is a bunch of Python files, then sure, make an SBOM of those. But typically it's a container if you're in kube land. And so I just wanted to throw that out there.
Yes, absolutely, absolutely. And speaking of the Wolfi and the base images, and Adolfo is behind the company that is actually made some of the Chainguard images, and that is close to zero CVE, smaller in size, and they built for the cloud native era. And now Adolfo will let us know how they experience how they experience some of the interaction with those images from customers, for the community they're working on. So, Adolfo, can you share your thoughts on Wolfi and the base images story on this part?
Yeah, so the Chainguard images, we have a catalog of images which are intended to be minimal, and they are intended to be a good replacement for those standard images that people use. And the cool thing about those images is that they come with all of the supply chain fixtures already built in, and one of them is the SBOM. And yeah, just like Rob was saying, so the images are already built, and the key thing with the SBOMs that we have in them is that they get built as, so our images are based on Wolfi, which is a new Linux on distribution, we call it, because it's a Linux without Linux. It's just the packages, because it's intended to run inside of container images. So Wolfi is an open source project and has lots of contributors from the community who actually submit new packages as people need them. And right from the point where we build those packages, we start generating the SBOMs. And we do capture the ideas that we will capture from the source, whatever we need, into the SBOMs. But those SBOMs are an aggregation. The SBOM that you get in the final image is an aggregation of all the steps that go into building that image. So those SBOMs are born at the point where the package gets compiled, and then we package that package SBOM inside of the package. And then when you build the image, it aggregates all of those SBOMs to create the next one. And then once you publish the image, it comes out with a comprehensive SBOM of what's inside of the image. And those images, I mean, that's just one of the features. And the way we've been trying to keep them small, and I mean, the way we've been trying to keep the volume count low is mostly a set of good practices, like patch quickly, react quickly in an automated fashion whenever issues get fixed. Sometimes we don't even wait for those patches to be released. Sometimes if the patch is available, we will pull it into Wolfi even before the project itself got a release with it. So it's mostly hard work, good practices gone into the image that reflects on the low vulnerability count.
Yes, absolutely. And let's talk about the new notion, the new standard, or new approach that has been actually developing in the software supply chain. There's a concept called the VEX. A VEX artifact helps software producer and vendors more quickly and efficiently identify, track, and communicate vulnerabilities and their potential to be exploited. So, can you, Rob, share your opinion on VEX? And we talk about OpenVEX as well. So, over to you, Rob.
Yeah, I think this is a super important part of, like I mentioned at the top, our mission is to kind of like tame the fire hose around vulnerabilities. A large enterprise might be tracking hundreds of thousands or possibly 1 million different vulnerabilities across all their applications. And what you need to understand, especially if you need to communicate that information to other people, like if you produce software, is which of those actually matter to me. And it's a tricky problem. And I think the VEX standard is a great one to encode into metadata, machine readable information what of these do I actually care about? The method that we take for this is we kind of call this a real-time SBOM, which is like on my servers right now, like which of these applications and libraries am I actually using like in production? Like really the Linux kernel has given this thing RAM to run. And we think that that's like the best filtering mechanism for this fire hose. You can imagine that's basically the exact same information that you want to capture in a VEX report. Oh, this Python thing is vulnerable to this CVE and this CVE. Yes, the kernel has given it RAM. It is actually running. And if that pod in Kubernetes or that machine in EC2 is connected to the internet, boom, you're vulnerable. And so capturing that information in a way that your customers can consume it as well as your security operations team can consume it is really, really important.
Yes, absolutely. Before we go into the Adolfo, can you tell us about the difference between the SBOM and the real-time SBOM? How we actually can differentiate between two things?
Yeah, you can think of it as like one pops out of your build system and one pops out of like a live Linux server. And so you can compare the two, especially when, that same container is running in both places. Or, you have a collection of containers running on one system. The interesting thing about this is that we like the concept of real-time SBOM because it aggregates the kind of trust content of both the host OS and all the containers. And so because we're deep inside the kernel, we can cut through the Linux C groups and understand exactly, even if you like bind mounted an executable from the host into a container and we're executing it and trying to, be tricky, we can see all that stuff because we're cutting across it. And so what it does is give you a really good insight into like literally what is the exploitability of this server right here and all of its workloads. So when you combine that with what you know about the workloads from the build side and the run side, it's really, really powerful.
Yes, absolutely. That's make perfectly sense to me now. And Adolfo, we see in the Chainguard we have the VEX CTL command line. And can you tell us first about what the VEX is, how it's different from the SBOM, how it's actually helped the SBOM? And then definitely there's a new thing in the Chainguard world, or there's an OpenVEX standard. I've seen some of the box port ready is available. So three things: VEX CTL, and OpenVEX.
Yeah. So exactly, VEX is the Vulnerability Exploitability Exchange. That's what it stands for. And the idea of VEX is once you have all of this new extra information about the supply chain and the components that you're running and coming in at you from a barrage of SBOMs that are flowing towards you, you start getting more and more, let's say, false positives, right? That's one of the key things that VEX addresses. And we actually saw this at Chainguard at some point. In our images, we started adding to the SBOM all of the information about the build environment that created the packages, like what kind of libraries were used to compile it, the language of the compiler, all of the environment was captured into the SBOM. And the first thing we noticed is that once we fed that into the scanners, they picked it up and they started reporting false positives about that artifact. But even then, even in those reports were about software that wasn't shipped with the SBOM. So those would be ideal candidates for vexing. But at the same time, we figured it was maybe too early to start shipping that information. So we recanted on that. But it's just an idea. It's just a use case to give you an idea of where VEX fits in. So VEX is not it's not a specification. It's more of a concept, and this is not a Chainguard project. It's there's actually a VEX community which is run by CISA from the U.S. government, and they enable this space for people to decide how VEX should look like. And there are now 3 VEX implementations. So CSAF is one of the standard supporting VEX. The Cyclone DX has their own version of VEX, and now we have OpenVEX. All of them are kind of geared towards their market and use cases. So CSAF is used to disclose vulnerabilities in like large enterprise projects. So they now have the ability to ship VEX in there. Cyclone DX has their own version of VEX inside of the standard. And well, some of us were thinking, well, we need like a lighter version of VEX, like just to convey VEX information, and that's it. And the reason why we needed it was because we want to see VEX being able to, one, be at like the VEX information be able to embed it into other formats. And the second one was that we needed to be like agnostic to the SBOM standards currently, right? And there's a fourth one coming from SPDX. So SPDX 3 is going to have its own version of VEX. So the VEX community was heavily discussing the final shape of VEX for the second half of 2022. And like we were discussing how the information should look like, how do we make it interoperable into the current implementations. And we finally came out with a document of the minimal requirements for VEX, right? And this is what OpenVEX is. It's an implementation as minimal as possible of that standard. And yeah, this began as an internal experiment of how a minimal VEX could look like. More people started like showing interest, so that we said, well, let's spin it out as an open source project. And it gained interest, and we have now several companies, not just us, involved in the project. And it's been now donated to the OpenSSF, the Open Source Security Foundation. And it's we just ran the first community meeting under the OpenSSF this week or last week, and everybody's welcome to join to participate.
Yes, absolutely. I think I watched one of the presentation Dan Lawrence gave on that presentation as well. And that's really excited me because the discussion was happening around like scanners give you the false information. Let's say you have something vulnerable in node package that is not the node official package, but is, let's say, SIME repository that containing the node packages. And then the scanners is actually defining that this package, the Node.js package, is having vulnerabilities inside, but that's not the Node.js package, but the repository where I'm actually using the Node.js images that's coming up. So these are the conversation happening, and then actually, I think Dan show how the VEX and OpenVEX is actually give you the document so you can actually get rid of these false information. So that is, I think, nitty gritty details into it, because the right now scanners is putting a lot of the information, the CVEs, that not be counted as any threat of any kind, but they still input information. And some very traditional and the sharp people and the security people that want no CVE, they get rid of zero CVEs, and then actually breaking the code, breaking the cycle of development and the security things. So I think the VEX is actually moving in a great direction right now. So now, Rob, because you discussed VEX in this picture, so can you tell us a way like how we can get started with VEX, OpenVEX, these kind of things in our some of the projects? What are the different ways we can generate VEX document or create, like we can use command line utility? What is the recommended way to use VEX today?
Adolfo probably has more insight in this than I do, but VEX CTL is probably going to be at least on the OpenVEX side, the easiest way to do that. What we're excited about on our kind of real-time SBOM side of it is generating VEX reports themselves directly from what's going on your live server. And so you can imagine you've got a CI run that's happening, and you check in a new dependency or you upgrade a new dependency, and it's like, hey, 2 new CVEs in that one, like FYI, you might want to go fix that. And it's like, well, actually, we're noticing that this code never actually runs in production. So like that's basically a confirmed negative match saying, hey, yeah, you don't need to care about those. Or, I mean, you should fix every CVE, but like maybe deprioritize those two, not an issue. And so we're excited to roll that out into our product. And I'll kick it over to Adolfo. I don't know if you have any other favorite tools for authoring VEX documents.
Yeah, this is like a really good use case. So right now, the focus on the VEX community, not OpenVEX, but the broader VEX community, is who should issue VEX documents, right? Like, if you think about it, if you think about VEX, because VEX the VEX information gets born somewhere, and its final destination should be kind of your scanner or vulnerability management tool, right? That crosses the vulnerability data with VEX, like removes everything that doesn't really apply to your project and gives you a better overview. But who can actually issue those VEX documents? And if you think about it, like the quick one would be like, well, obviously the original author of the project, but there are a lot of players in between that can also issue VEX documents. And for example, the original project can issue a VEX document. If I'm repackaging software, I may issue another VEX document. Then there may be like the exact example that Rob just gave. Like if you have internal processes, tools, or even an app security team that you trust to do the analysis for you, they can also issue VEX documents, right? So this is why we work really hard for VEX information to be composable, so that you can take the information that you care about, combine them, and give you a really good assessment, a final assessment on what actually applies, which vulnerabilities actually impact your software, your piece of software. Where it may come, it can. So our goal is to have one central tool that generates the documents, and you can work with them. So that this is the goal of the project. So and our initial goal is that if you're an open source project, for example, or you have any project like releasing software, and you already have a vulnerability disclosure process, right? Then we want to make it really easy for you to generate those documents along with your vulnerability disclosure and analysis process. So VEX CTL is, so OpenVEX right now, what is OpenVEX? OpenVEX is a specification. It's a Go library that lets you work with those documents. And we have VEX-CTL. And VEX-CTL is a tiny CLI that lets you create documents. It lets you get two documents and merge them into one, and lets you filter. For example, if you have one VEX document talking about, let's say, 10 pieces of software, it lets you filter for those you care about and do all of this combinatorics with the documents to get the one you need. And it finally lets you create attestations of those documents and sign them. This is what it does. And we, in the VEX, in the first OpenVEX community meeting, what we wanted was like try to get an open call for software authors to join and see what their VEX history would look like. So I know that there are a ton of people, and we've heard, like, I mean, if you've heard, for example, if you follow Daniel, the author of Curl on Twitter, he's always receiving all of these reports. This is the people that we want to help. Like, we want to help them issue those documents so that they can start flowing VEX information down. But the other use cases, like getting other, like, I don't know, like EdgeBit generating OpenVEX documents would be like fantastic, because you can see and start working with a whole flow of VEX documents. And this is going to really help us understand, one, who are the personas who should issue VEX documents, one, and the second one is, do we have the trust model right? Like, how do I know who should be issuing those VEX documents? Because it's ultimately the scanner needs to know who to trust, right? Or at least you need to be able to tell them which documents to honor.
Yes, absolutely. So if we can orchestrate all this information, let's say OpenVEX and the VEX came into the picture, then how the things orchestrate in the future? Like now we have, like, say, we start with the basic container images, and the Chainguard has wonderful images, and these are actually coming up quite nicely for all the images. And one thing I really like about the documentation side is you go to the Chainguard website, you have an integrated terminal that can help you learn how to use these Chainguard images. I really like about this approach. One of my tweets is actually really appreciate this effort. So you can go check that out as well. So I'm thinking, like, if the orchestration piece works, like you first work with a basic Chainguard images or base images that has zero vulnerabilities inside, then you actually go use SBOM information inside it. Then there is a VEX document that might be feed into the vulnerability scanners, and they can look at this document to then let you decide that is this exploit is actually a threat or not. So this is how I'm actually grabbing my heads around as well. So how this information flows inside as well. So before we let off today's talk as well, so can you let the audience know, specifically for the Rob as well, so can you let us the people know if they are actually really new to this game of supply chain security, and this game is actually changing every day, and that might be a very frustrating for everyone. The new standard, new specification, new tools, new libraries, new base images, so much coming up, and they're wrapping their head around like, where should I start from, because I'm actually new to this game. So can you, Rob, give some pointers for specifically those companies and the people they are actually just thinking about supply chain security from now or from today?
Yeah, I would say, I mean, if you're looking for like a step one, is just like start producing SBOMs for your software and getting that into like your practice. Like you don't even like, you should, there's lots of good things to do with those SBOMs, but just get them running in CI, start producing them, start getting familiar with what, what shows up, how to aggregate them together, how to store them, how to audit them. Our software at EdgeBit can help. There's a ton of other pieces of software as well. I would just say start getting your hands on building this stuff is the easiest way to understand like what is Cyclone DX versus SPDX? What do those files look like? How is it useful or not useful? I think like as Adolfo mentioned, when the VEX documents are included in Cyclone DX versus sitting beside like an SPDX document, you can start messing with them a little bit more when they're separate versus when they're together. Figure out which one of those you like. I think there's like a bunch of stuff you can learn by just getting your hands on stuff. One point I wanted to make around like VEX existing in the first place is great because probably the scariest part of getting started with SBOMs, especially if you were a software vendor, like you produce software, is, oh my gosh, I'm going to give people a look under the covers as to what's going on, or like, what if I have all these vulnerabilities? Well, you're going to have tons of vulnerabilities. Like there's like our sprawling supply chains are just very large. And so, and unless you want to break upstream packaging, like you need to be able to consume new versions of open source. And so that means you can't start messing with it too much. Because you want to be able to cleanly upgrade from version A to version B. So that's just going to come with vulnerabilities. But if you have VEX information, then it doesn't look as scary to your customers. You can say, hey, look, yeah, there's 10,000 vulnerabilities in this thing. It's because we have a large surface area, but 9,580 of those don't matter. The rest of them are scored medium and low, and these ones are high, and here's our mitigation for it. It starts to feel a lot better to anybody that is both consuming or publishing that stuff. And so I think it's like the full ecosystem is really important there. You got to not just do one, you got to kind of do everything.
Yes, absolutely. Totally agree. I think it's a human psychology as well. Like if you see a red flag in front of you, your brain started to thinking less because it's hijacked by these red flags. There's, oh, now we have 20 vulnerabilities to fix. And if somebody tell you out of these 20 vulnerabilities or the high severity, only one is critical, then you might start to relax a bit and you can think about making sure how this one of them can be go away. Prior to that, you're thinking about these 20s goes away. So I think that is other the mindset as well. And also, Adolfo, from yours, we start about the supply chain and how we can start it. I think we did a wonderful episode with you on this channel way back in, I think, the KubeCon last year, how to start learning supply chain security. And you draw a wonderful point on, I really, some of the community people really appreciate this episode, especially for how you define some of the concepts of the supply chain security. So now the question around is the ecosystem. Now the ecosystem is getting more and more mature every day. Supply chain security is being, I think, being conversated a lot of the time, not just in the Kubernetes. I remember when we talk about the Kubernetes, we're just thinking about how you can secure your cluster. We're not talking about the integrated details of how you can secure your images, how you can secure your container registries. You're just talking about how you secure your cluster. Somebody is not hop into your cluster and be via VPN and just start getting with the RBAC or these kind of. But right now, this discussion in Kubernetes ecosystem is mostly around how you're able to make sure your container images are secure. You are the OCI compliant. Your GitOps tool is actually making sure your images that you're pulling from is actually doesn't contain vulnerabilities, and we have policy engines on top of it. We have a cosign tool that lets you do these kind of stuff as well. So being a software developer, like I am a software developer, I start developing my application from today. Now the supply chain security is actually more visible to me. What should I do while developing my application?
Yeah, well, I guess supply chain security is like a really big and complex thing, but one of the most effective ways to have secure workloads is to have enough information that you can draft good policy on what you want to see. And I think this is why, for example, if you see, because one comment I wanted to add to what Rob just said is that VEX is also about this dialogue, or at least I wouldn't say dialogue, but because it's more of a unilateral, but it's about communication with the final consumer of your software piece. Because VEX will tell you if a vulnerability it impacts your software or not, but also why. Because you may have that scenarios where the component is not present in your software piece, but it may be that it's not executable. And one is more easily to verify if someone tells you this software is not inside of my piece of software. But when someone tells you, well, I checked this piece of software and this vulnerability cannot be executed. This is more of a judgment call, and you may say, well, I'm not sure I'm going to trust that part, right? And then you would need external tools like Rob's, like to make the actual analysis of it, if it's actually getting executed or not. But the nice part about VEX is that it gives you this information where you can decide which parts to trust and which parts you don't want to trust. And the other one is it also lets you know the status of the fix, right? Because once a CVE pops out, the first status that you may see in VEX is, okay, this is under investigation. We know the CVE exists. We're checking it. And this may be your first indication if you're like trying to run an airtight operation. Okay, I know about this. Kill all of the workloads running this, right? And then your vendor may come up with another VEX message saying, okay, we checked and it's not vulnerable, or we fixed it. So it's about this communication. And going back to how you can start is you want to make sure that your workloads, your software, your project is actually producing and releasing as much information as possible around this. And I think right now the two most important that you want to ensure that you're producing are, one, the SBOM, because the SBOM is kind of the base layer of the supply chain security stack. And then the second one is try to start thinking about generating provenance metadata. That is, how did I build this? Who built it? Under what tools did it actually build in the builder I was expecting it to run? Because if you have visibility into those, you can make a really good judgment call on what you allow to run inside of your clusters or not. And I am part of the Kubernetes SIG release a special interest group, and we will be presenting at KubeCon a rough guide on how projects can start. This is geared towards the cloud native world, but actually any project can use it. And so we've been trying to come up. We've been writing a lot of software to generate this kind of information in Kubernetes. So we have our own SBOM tool. We have our own provenance metadata. We have tools to release, to got releases in GitHub. So we have a ton of little utilities that you can use. And during KubeCon, we're going to do a talk like trying to come up with a guide that anybody can follow to, like, okay, take our tools and put them into your repo, and you're going to get like all of these things working together. If someone wants to start on that, I recommend it. I'm going to be speaking with Carlos Panato, who is the other tech lead, my co-tech lead in Kubernetes release. So I encourage you to join and watch that talk.
Yes, and Carlos is here. Your friend is actually on the chat. Carlos, thank you for joining. Great to see you there as well. And that's absolutely, I think, great idea for this. I think we should kind of have some kind of supply chain security roadmap available for us, because as a developer, there is a quite. I think this ecosystem is being developer know things how work, but the system is changed actually. Now the developer is making the containers first, and then he makes sure the container images are smaller in size. Then they make sure when they're pushing the container images into the registry, those are signed, and then somebody, another developer is using that images. They make sure they are verified from the trusted source. So there is a quite a bit of information is being flowing, and that needed some kind of guidance as well. I'm more than happy to take my part in it as well. So we talk about the developers approach as well. I think if we can end the podcast without talking about the platforms or the security engineers and now what their responsibilities are. I think the responsibility is same, but now they're implementing the responsibility quite be different from the traditional way of implementing those compliance. So Rob, can you share some guidance for the platform engineers or might be the security compliance engineer, what they are most responsible for as of today?
Yeah, I mean, it comes down to making use of the information that is coming out of CI and from those developers. And I would you could think about it this way, back before the days where status pages were all like automated and had a bunch of graphs, like when you were trying to debug an issue and the status page wasn't updated, you were really, really frustrated, right? Like you just didn't know what was going on. The same thing is now true for like the handoff of this metadata from developers to operations teams or security teams. If they don't understand what's inside of an application, like how can they do their job? They don't have the status of it. And so getting all this metadata just coming out of CI and providing it to those teams is already like the step in the right direction. You know, as something's going on, you just give them the status. And then it's all about verifying provenance, like Adolfo was saying, making sure signatures are checked, making sure the policies inside of those applications match your org's policies. And I think most critical is just having even a live inventory of what stuff is where. You'd be surprised, like all these very cutting edge cloud native shops, you know, it's like, oh, everything is in Kubernetes. So we just do kubectl get pods dash all namespaces and like, boom, that's our software inventory. Well, that doesn't cut it, especially when you're across clusters. You've got some people that are deploying directly to EC2. You've got other bare metal systems in use, whatever, and there aren't APIs. Even just having a live inventory is like a big problem for a platform team. And then once you've got that inventory, it's like, oh, now I got to tie it back to like, again, what builder did this pop out of, or like what Git repo even makes this thing, are like pretty hard problems to solve. And so once you have the metadata, you can start putting them together as a platform team.
Yes, absolutely, absolutely. That's a super useful information for us. So I won't take much of your time, but it's been a wonderful. I learned a lot about it today on this podcast, and definitely I think it's been a very new things coming up, especially the VEX side, the OpenVEX side. I see what exactly the noise is getting into. I see already noise being populated for the VEX before the KubeCon, and I know when the KubeCon started, we come up some with more news, more involvement. But I think it's worth. I think it's a needed. It's absolutely needed today that the scanners show me the correct result. Otherwise, we lost focus in engineering. We can't fix things because we think scanner doing wrong, telling us wrong things, and we are actually solving those problems. Let's say I'm a security lead engineer. I look at the scanner. I ask my team, let's go fix this. And he spent 40 hours fixing this thing. But at the end of the day, this code doesn't go into the production. At the end of the day, this code is actually being not threatened to me at all. VEX is absolutely necessary. And I think if VEX is necessary, then this means Rob and Adolfo will be appear again in this show. after some time, might be after the KubeCon, and give us a more update about how the VEX ecosystem is being developing. And this is the area in KubeCon you need to be focused on more. And I'm actually keeping my eyes on out as well. So before we let you go, let's wind a recap of today. So vulnerability exploitable exchange, or VEX, is a mechanism designed to help organization more efficiently assess and manage vulnerabilities in their software. OpenVEX is a powerful tool that brings transparency and automation to software security. It allows for an accurate understanding of applicability of vulnerabilities, finding to software products, reducing false positive alerts, and increase the efficiency of security scans. For these words, I will conclude the podcast. And any final words from the Rob and Adolfo before we let go?
I would say thank you for having me on. Appreciate it. And yeah, happy to come back on and talk about all the latest and greatest. Thank you.
Yes. Adolfo?
And yeah, again, yeah, thank you for having us, Simon. Nice meeting you, Rob. And I encourage anybody interested in talking VEX to join our OpenSSF calls. It's on the OpenSSF community calendar, and everybody's welcome.
Yes, absolutely. So these are the links. Here's the Chainguard link. The company behind making software by default is the EdgeBit that the Rob is actually working on. So go check that out. And if you have any information, Rob is the person to contact. What an SBOM can do for you. That is one of my favorite articles on the internet. It's a wonderful example showcasing how the information flows. OpenVEX Specification, VEX Supercharges SBOM. Here's the link I will add on the YouTube description as well. Chainguard Images, go check that out. It's being populated every day. I don't see a tweet from Dan Loris is not mentioning there's a new Chainguard Images available in our library. It's very hard to see these days. There's a Wolfi OS, and you should check that out. The community calls opening up every week. So this is you should join as well. I did a podcast on cloud container images for cloud native era for Iroka Heidi. He's give us wonderful. So go check that out. Learning supply chain security on this channel. You can look at the talk of this Adolfo, and you can subscribe to channel. You can look at follow the Twitter handle. KubeCon coming up. So go check that out. Registered, and if you be in there. I think Rob is not there, but Adolfo and his team will be there, so can start discussing this concept. With all these details, thank you very much for tuning in and joining us today on the live podcast. We'll be back again with more news with Adolfo and Rob. And meanwhile, we are very thankful for them to give us their knowledge about software supply chain security. Bye-bye, everyone. Stay safe and stay healthy.